All right, today we're going to talk about the future. But not the 5G we have now, or even the 6G people are starting to map out. No, we're jumping way ahead, into a vision for 7G that sounds like it was pulled straight from science fiction. This isn't just about faster downloads. It's about a world where technology is completely, fundamentally different. Let's get into it.
So I want you to start with this one simple question. Just for a second, forget everything else. Imagine a world where our devices don't need wires. They don't need batteries. They don't even need electricity the way we think about it today. What would that even look like? Because that's the core idea, the absolute foundation of the whole 7G concept we're exploring. You know, to really get this, you have to see the difference. We're already heading towards 6G, this idea of a smart environment, right? You walk into a room, the lights turn on, the music you like starts playing. It's all about things responding to you. It's convenient, sure, but it's also always on, always watching, always sensing. 7G, well, it completely flips that script. It's about a sovereign environment, a world you actively choose to interact with, not as some consumer being catered to, but as an equal. So why would we want to make such a radical leap? Well, the dream behind it all really boils down to two huge goals. First, to create a world that isn't constantly bathed in the electromagnetic fields that all our current tech puts out. And second, to build a digital world where personal privacy isn't some setting you have to hunt for in a menu. It's the absolute fundamental law of the system itself.
Okay, so how on earth do you even begin to build a world like that? Well, you have to start at the bottom, by reinventing the single most fundamental piece of modern tech, the computer chip. And we're not talking about a simple upgrade here. This is a complete teardown and rethink of how everything works.
The magic behind this is a technology called photonic computing. Basically, instead of pushing electrons through copper wires, which creates heat and slows things down, you're sending light, photons, through tiny little channels. So your data literally moves at the speed of light because your data is light. No electricity, no current, no wires. And this is where things get really wild. The vision for this world could be powered by some seriously mind-bending technologies. You've got the photonic chips we just talked about, but also things like quantum spintronics, which uses the spin of an electron itself to hold data, or even neuromorphic chips that are designed to work just like the neurons in a human brain. I mean, it sounds like sci-fi because, honestly, a lot of it still is.
So if there's no electricity, the big question is, how do they even run? Well, they become energy scavengers. These devices would just sip power from the world around them. We're talking about tiny vibrations in a building, the difference in temperature between two surfaces, your own body heat, or even stray radio waves floating in the air. They just become part of the natural energy flow of the environment.
And this perfectly captures what that means. You know, one of the biggest limiting factors in computing today is heat. Your phone gets hot, your laptop fan spins up, it's all wasted energy. Well, if you get rid of electricity, you get rid of the heat problem. The source material put it perfectly. These devices would run cooler than a cucumber in a snowstorm. It's a funny image, but it gets the point across. This tech is fundamentally cool, literally.
Okay, so we've got these tiny, powerless, revolutionary chips. But what happens when you connect millions or even billions of them together? You don't just get a faster version of the internet. No, you get something totally new. You get a reality that starts to function like a single, planet-sized operating system.
And this table, wow, it really lays out the massive philosophical gap here. Just look at the user role. In 6G, you're a consumer. In 7G, you become a sovereign node. Privacy goes from being just another feature you have to manage to being the foundational protocol of the entire system. And the energy use? That's the knockout blow. We go from today's power-guzzling data centers to a system that has almost zero net energy use because it just lives off its surroundings.
And that's the biggest idea of all. The network isn't in the cloud anymore. It's not stored on some company's giant server farm. The network is the world. Every object, every person who chooses to join in becomes a part of this living, breathing, decentralized OS that just emerges from all the interactions between its parts.
The benefits of a network like this? Oh, they'd be absolutely revolutionary. Latency, lag, it would basically disappear. The network would be woven into the very fabric of our world, with buildings themselves maybe acting as antennas. And just imagine, no more massive, energy-sucking data centers. Even better, all the old ways of hacking that rely on electrical signals, they just wouldn't work anymore.
So we've talked about the tech, we've talked about the network, but what does all of this actually mean for you? How would you exist in a world like this? Let's bring it down to a personal level.
See, interacting with this world is always a conscious choice. It's not something that just happens to you. You'd walk into a 7G-enabled area, and then you would choose to instantiate, which is a fancy way of saying you become a temporary active object in the system, and from that moment on, you are in complete and total control. You decide what to share, you set your own privacy rules, and you interact as an equal, not as some product being tracked.
And here's where the privacy model gets really interesting, and frankly, kind of brilliant. Your level of privacy could be based on how many other nodes or objects are around you. So if you're out in the middle of nowhere, maybe you're completely invisible. Sitting in a crowded cafe with friends, maybe you open up a little, but only to nodes you trust. You get to set those rules.
And this one quote from the source material just perfectly sums up the entire philosophy. It's a shift away from an internet of things, smart toasters and fridges that serve us, and toward an ecosystem of sovereigns, where independent entities, including us, all choose to interact with each other.
And for all you tinkerers and hackers out there, you're going to love this part. The whole system is imagined as being completely open source. You could literally roll your own custom nodes, write your own code for how you interact, and basically design your own place within this global OS. It's the ultimate version of digital freedom. Now, as absolutely incredible as all this sounds, we have to pump the brakes for a second and be honest. A vision this big, this revolutionary, comes with challenges that are just as massive. So let's ground this amazing dream in a little bit of reality.
The obstacles here, they are not small. I mean, the special materials we'd need for these photonic chips, we can't make them at scale yet. That's a Nobel Prize level problem right there. And compatibility? How do you even begin to migrate our entire global infrastructure from electricity to light? It would be a nightmare. And what happens when a million nodes are all trying to interact on one city block? Then you've got the huge social questions, like what about people who don't want to be a node? And of course, there would be new security threats we can't even imagine, things like photon spoofing.
So yeah, that's really the best way to think about this whole thing. This isn't just the next step up from 6G. This is a fundamental change in how we do everything. It's a leap as big as going from old-school steam engines straight to the warp drives you see in Star Trek. So, that's the 7G vision in a nutshell. On one hand, it offers this incredible future of total privacy, sustainability, and personal freedom. But on the other, the path to get there is blocked by some of the biggest scientific and logistical challenges imaginable. So I'll leave you with this question. Is this the blueprint for our digital future, or is it destined to remain a beautiful but ultimately unattainable dream?